Bernoulli's equation. Solve the differential equation 3 sine y minus 5x times dx plus 2x squared times cotangent of y dy equals 0. The standard form for Bernoulli's equation is dy over dx plus p of x y equals q of x times y to the n. Here's the given equation again. So our first goal here is to transform this equation into a Bernoulli's equation standard form. Cotangent of y dy is just cosine of y over sine of y. Next, we're going to let z equals sine y, and that will give us our dz is equal to cosine of y. Okay, next we substitute z equals sine y, so we now have 3z for this, and then dz for cosine y dy, and again z for sine y. So we have 3z minus 5x dx plus 2x squared times dz over z. Now looking at the equation, there's only one term containing dz, this one. So that would mean that our dependent variable would be z, and our independent variable would be x. So we will multiply this equation by this z over 2x squared over dx. Z, so that we can cancel out this z here. Then 2x squared will cancel out this one. And we now have for the last term dz over dx, similar to this one. Okay, so let's multiply. 3z times z is 3z squared divided by 2x squared. We have divided by 2x squared, and then dx will cancel out. So next we divide negative 5x by 2x squared. We have 5 over 2x. So the x here will cancel. So we only have 2x in the denominator. Then multiply it by z. We have z here, and then dx will cancel. And for the last term, we have z will cancel. Then 2x squared will also cancel. So we are left with dz divided by dx is 1. dz over dx. And then we will rearrange that one. We have dz over dx minus 5 over 2x times z equals negative 3 over 2x squared times z squared. So this is now a Bernoulli's equation. Our dependent variable here is z, and then our n is 2. Okay, to solve Bernoulli's equation, we are going to reduce this into a standard form for the first order linear differential equation. So the standard form for first order linear differential equation is dy over dx plus p of x y equals q of x. So if you can see, there is no dependent variable here with an exponent. So we are going to eliminate this one by multiplying the whole equation by z to the negative 2. So we have for the first term z to the negative 2 times dz over dx. Second term now becomes 5 over 2x times z. So that's z times z to the negative 2, or that will be z raised to the power of 1 minus 2, which gives z to the negative 1 equals, right side of the equation, z squared will just cancel out. And we have minus 3 over 2x squared. Okay, so this is almost the standard form of a first order linear differential equation. The only difference here is this coefficient of z to the negative 2 and this exponent here of negative 1. So we're going to do another substitution. This time we let w equals z to the negative 1, and it follows that dw is negative z raised to the negative 2 dz, or z to the negative 2 dz is negative dw. Then we'll substitute this one here. and this w here. So we now have negative dw divided by dx minus 5 over 2x times w equals negative 3 over 2x squared. So this is now a first order linear differential equation, which is linear in w. W here is our dependent variable. Okay, so next we will multiply the whole equation by negative 1, so we will get rid of this negative signs here. So multiply that by negative 1, we'll get dw over dx plus 5 over 2xw equals 3 over 2x squared. To solve first order linear differential equation, we are going to find an integrating factor. Okay, so we will define our p of x, that is the coefficient of w, which is 5 over 2x, and our q of x is the function on the right side of the equation, which is 3 divided by 2x squared. And then we find the integral of p of x dx, which is integral of 5 over 2x dx equals 5 over 2 times the integral of dx over x. And this is equal to 5 halves times the ln of x. So the integral of p of x dx is equal to ln of x to the 5 halves. Now our integrating factor u equals a to the integral of p of x dx is a to the ln of x to the 5 halves, or it's just u equals x to the 5 halves. Next, we will multiply this integrating factor here, or we can use this formula. The integrating factor u times the dependent variable w equals the integral of the integrating factor u times q of x dx. Okay, so u, which is x to the 5 halves, is this one, times w equals the integral of u, which is again x to the 5 halves, times q of x, which is this one. Q of x is 3 over 2x squared times dx. X to the 5 halves divided by x squared is x to the 1 half. And the integral of that is x to the 3 halves over 3 halves. So which cancels this 3 halves here. Then we get x to the 5 halves w is equal to x to the 3 halves plus c. And now our w is equal to, this w here is equal to z to the negative 1. Okay, so next we are going to eliminate this term with a negative sign here, and that can be done by multiplying the whole equation by z, because z to the negative 1 times z is equal to z to the 0 or 1. So we have this equation now, x to the 5 halves equals z times this is x to the 3 halves times z plus c times z. Then we transpose x to the 3 halves times z to the left side of the equation, becomes negative x to the 3 halves times z. Then we get the common factor of x to the 3 halves. So we're left with z here on the second term. This one, 5 halves minus 3 halves is x to the 2 over 2, or x to the first power, or just x. Then we want to get rid of this fractional exponent. So what we're going to do is we can raise the whole equation by 2. So we have x cubed times x minus z squared equals cz squared. And then, but z is equal to this. So substituting that back here, we now have our final answer, x cubed times x minus sine y quantity square equals c times sine square y.